Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Hope you are fine. Dear students, this lecture is for grade 7, subject science. And in this lecture, we will do the remaining topics of chapter number 9. Also, we will start another chapter, which is about the sound waves, chapter number 10. This is my 27th lecture, and I am your lecturer, Mrs. Saira Jamal. Colors of light, as in my previous lecture about I told you about the colors of light, that by mixing primary colors we can get secondary colors, and we discussed the mixing of these colors. When red and blue lights we mix together them, then it will give us magenta color. By mixing red and green will give us yellow color, and by mixing blue and green will give us cyan color, and by mixing all these three colors it will give us white color. So this is about the colors. By mixing primary colors we can get the secondary colors. So magenta, yellow, cyan, white, these are the secondary colors. In order to understand the mixing of colors, we have an activity 9.6, which is about the mixing the colors of light. For this activity, you will need three torches: red, blue, green torches, and cellophane papers. Cellophane papers. Procedure is that take three torches, paste a green cellophane paper to one torch, then a blue cellophane paper to another torch, and red cellophane paper to the third torch. Then throw lights of different colors on a white screen, use white screen, and throw lights of all these torches on the white screen in such a way that light of one color falls on the light of the other color. Observe mixing of colors and fill the table. You will observe the mixing of different color. You can see that the color mixed together and will give us the secondary color. The primary colors, they mix together and will give us the secondary colors. So in a table, we will going to discuss about the mixing of these colors. You can see, and I already explained you in my previous lecture, that the colors after mixing together will give us the secondary colors. Then next one is about the colors of objects. How and why the objects appear colored. When white light shines on non-luminous object, they reflect some colors and absorb all the colors. You can see that the color of an object is the color of light it reflects. Keep this in your mind, that the color, the shirt appear red, it means that it reflects red light. It it absorbs the remaining light and it transmit the red color. And the trouser appear blue because it transmit the blue color and absorb the remaining color. And you know that the white color is composed of these seven different colors. So out of those seven different colors, the shirt will absorb the remaining all light, and they will mix together and will transmit the color of light is red. And in this case, the trouser will transmit the color of light that is blue in color. So the color of an object is the color of light it reflects. As I told you, a red object appears red because it reflects red color of light and absorbs all the other colors of light. Same is the grass of our lawn appears green as it reflects green color light into our eyes. And why does a blue car appear blue? Because it reflects the blue light. It absorbs the remaining all lights and will reflect only the blue light. That's why the blue car appears blue. Same is for all the objects. The color which the object reflect, the object will appear in that color. Like as there are seven colors in white light, but the shirt absorb all the other lights except it will reflect the red light, so the shirt appear red. And the trouser absorb all the other lights except the blue color. It reflect the blue color, and the trouser appear blue. Same is the case when some colors they are absorbed by the object, they will mix together and will give a secondary color, and that's why the object appear in that color. And when all the colors of light are absorbed by the object, it appears black. If all the colors are absorbed by the object, that object appear black. And if all the colors are reflected in our eye, then the object appear white. Okay. Black objects do not reflect any light, they absorb all lights. And white light does not absorb any color, they reflect all lights. That's why it appears white. You can see here the black object absorb all lights and appear black, and the white object reflect all color lights, and then it looks white. This is extend your thinking. What colors are reflected by an object that appears black? No color is reflected by the white light, the black object. It absorbs all the colors. Objects that appear white appear so because they reflect all wavelengths of light. As I told you, the white object reflects all wavelengths of light, while the black color absorbs all wavelengths of light. This is why black is sometimes defined as the absence of color. Key point of this chapter are, this was the last topic of the chapter. So key point of this chapter are, first one is refraction. When light passes from a transparent medium to another medium, it changes or it bends. Like from rare medium to denser medium, it changes or it bends. This bending of light is called refraction. Refraction causes image to form in our eyes. A rainbow to takes place. A rainbow also takes place due to this phenomena of refraction. And when light passes through a prism, it refracts and bends at an angle. And a prism can split white light into its component colors or into its 7 colors. Red, orange, yellow, green, blue, indigo, and violet, as I told you with Gaia, are the component colors of the white light. The band of 7 colors of light is called spectrum of light. All the 7 colors, they form a band, and that band is called spectrum. A rainbow disk has all the 7 colors of light. When it is spinned, white disk is seen. That was one of our activity in which we use the different colored papers on the disk, and when we rotate it, then the disk looks white. The reason is that all the colors are mixed together and will form a secondary color, which is white. Red, blue, and green are the 3 primary colors, and they combine together to give us secondary colors of lights. Cyan, magenta, and white, I told you, are the secondary colors. The color of an object is the color of light it reflects. That was just we discussed in the last slide. A red flower reflects a red color and appears red. A white surface reflects all colors of light and appears white. A black surface reflects no color. Coming toward the next chapter, chapter number 10, which is about the sound waves. Sound waves. Waves, in this chapter we will discuss waves and its types, then basic terms to understand waves. Then we will discuss the relationship of these important terms, then audible frequency range, pitch and frequency. Then we will discuss the applications of different sounds. So these are the main topics which we will discuss inshallah in this chapter number 10, which is about the sound waves. What is a wave? You know that a wave is a disturbance that transfers energy from one place to the other. A wave is a disturbance that transfers energy from one place to the other. You can see that when we throw a stone in a pool of water, waves are produced in water. When we throw a stone in pool of water, you can see the waves which are produced, and these waves are transferred and then in turn reaches to the maximum point. You can see these waves which are produced in water when we throw a stone in it. So waves can be produced in liquids, in gases, also in solids. Many waves require some material medium to travel through, and this material thing is called a medium. Medium is compulsory for the waves to produce, and gases like air, liquids like water, and solid like rope or metal all acts as a mediums where the waves are produced. Air is a medium, water is a medium, solid like rope or any metal, it all acts as a medium. In this case, you can see that waves are produced in water. For the production of waves, water acts as a medium, and then the waves produced in water when we throw a stone in a pool of water. Then types of waves. There are two types of waves. Those two types are transverse waves and longitudinal waves. Transverse waves and longitudinal waves. First of all, we will discuss transverse waves. What are transverse waves? A wave in which particles of the medium move perpendicularly to the direction of the wave is called a transverse wave. A wave in which particles of the medium move perpendicularly to the direction of the wave is called a transverse wave. In this case, this is one of the example of transverse wave, that is a rope, moving a rope. When the one end of the rope is tied with support, with a wall or any support, and another end is in our hand. When we will move the rope, what will happen? Waves will produce in the rope. You can see waves produced in the rope. So these waves which are produced in the rope, what is the medium for this wave? The wave medium for the wave is rope, solid. Rope is a solid, and it will give medium for these waves which are produced in the rope. So the waves which are produced in the rope is called the transfer wave. Transfer wave is the example of the moving a rope from the free end up and down. So which waves will produce in the rope? Transverse waves will produce in the rope. This is the example of transfer wave, and rope is providing a medium to the transfer wave. So the thing is that what is the medium? Medium is solid, and that is rope. Another thing is that you can see that the particles of the medium, means the particles of the rope, which is a medium, it will move perpendicularly. This is perpendicular because this is the way through which the wave is moving. The wave is moving from our hand towards the support, another support. So as the wave is moving from this left towards right, but the particles of the medium, means the particles of the rope, they are moving perpendicularly to the direction of propagation of a direction of propagation of wave, means that the way or the direction in which the wave is moving, that is called the propagation movement. Propagation means movement of the particle. So you can see that this straight line or this arrow show the perpendicular movement of the particles of the medium, because this is, I told you, imagine this is a straight line where the wave is moving. Same like in this case, you can see this straight line show that this is the way in which the wave is moving from left to right. But these waves are, you can see the wave is perpendicular. You know about the perpendicular. Perpendicular means the line which is making an angle of 90 degree with the surface. So the wave is making an angle of 90 degree with the surface. That's why we can say that the wave propagate perpendicularly to the direction of propagation. Direction of propagation means in which the wave is moving. So the waves are produced in water, are transfer waves. Waves produced in a rope are transfer waves. And in these waves, in transfer wave, the highest point, this is called highest point, and this is called the lowest point. Highest points are this one, 2, 3, 4. These four are the highest points, and 1, 2, 3. These three are the lowest point. The highest points in the transfer waves, it is called the crest. The highest point of a transfer wave is called a crest, and the lowest point between the two crests is called a trough. You can see that the lowest point, this is between two crests, one crest, two crests, and this is the lowest point, is called trough. The highest points in transfer waves are called crest, and the lowest point in a transfer waves are called the trough. And I told you the example of transfer waves. First of all, again, I'm repeating the definition of transfer wave: a wave in which particles of the medium, particles of the rope, in case of this example. And if we consider water, then water is the particle of water. They are moving in perpendicularly to the direction of the wave. Wave is moving from left to right, and the particles are perpendicular to the direction of the wave. This is direction of the wave, and waves are perpendicular on the direction of wave. So this type of wave is called transfer wave. Example of transfer wave is by moving the free end of a rope up and down, we can create transfer waves. Free end means one end of the rope is tied with support and the other end is free. So when by moving this free end of the rope, we can produce the transfer waves in the rope. Second type of wave is the longitudinal waves. So what are longitudinal waves? A wave in which particles of a medium move back and forth parallel to the direction of the wave is called a longitudinal wave. In this, the particles of a medium, the particles of a medium are moving parallel, not perpendicular. In transfer wave, I told you that the particles of the medium moves perpendicularly to the direction of the wave. But in this case, the particles are moving parallel to the direction of wave. Parallel means if the wave is moving from left to right, then the particles of the medium, in this case, the medium is provided by the slinky spring. This slinky spring, which is made up of plastic or any metal, it provides the medium. So the wave which produced in the slinky spring, you can see the wave is moving from left to right, and the particles of the slinky spring also moves from left to right. So both are in the same direction, and in this you can say that both are parallel to each other. Particles of the medium means particles of the slinky spring, and also the wave, they are parallel to each other, or they are moving in same direction from left to right. You can see this one is transfer wave. You can see, look, the particles are moving up and down, up and down. This up and down movement is called perpendicular motion of the particles perpendicularly to the direction of propagation of wave. But in this case, there is no perpendicular movement, just a straight movement, back and forth. Back and forth means same like the swing. As a swing, when swing is moving, so it is moving in forward direction as well as in backward direction. So forward and backward direction is called back and forth. So you can see here, same like the swing movement, the slinky spring particles also move back and forth, back and forth. When you pull the slinky spring, or when you hold it from this side as well as from this side, and when you pull the slinky spring and when you leave it, then the slinky spring will show this type of produce these type of waves, which are called longitudinal waves. So example of a longitudinal wave is the slinky spring. You can see here, this is the perpendicular motion of the medium along the direction of wave, and in this case parallel movement of the particles of the medium in the direction of wave. One more thing is that, as I told you, that the highest point in transfer wave is called crest and the lowest point is called trough. But in longitudinal wave, there is no crest and trough. We call it compression and rarefaction. You can see when all the coils in the slinky spring, if they are close to each other, then that close points are called compressions. Compressed, tightly packed together, compressed, and compression. And those particles which are farther apart from each other, the coils which are farther apart from each other, that point is called rarefaction. Again, compression, rarefaction, compression, rarefaction, compression, rarefaction, and compression. So in longitudinal wave, there are compression and rarefaction when the coils are close to each other or tightly packed to each other, and the others which are farther apart from each other, then that part is called rarefaction. So in slinky spring, compression and rarefactions are produced. Example of longitudinal wave is slinky spring. If we pull and push one end of the slinky spring continuously, we can produce a longitudinal wave. The parts of the longitudinal wave where particles of the medium are compressed together, they are called compression. As I told you, particles of the medium again I told you is the slinky spring, and these are the particles of the slinky spring. When they are close together or packed together, then that part of the wave is called compression. The parts of a longitudinal wave where particles of the medium are compressed together are called compression, and the parts of a longitudinal wave where particles of the medium are spread out or they are farther apart from each other are called rarefactions. As the wave moves, compressions and rarefactions are produced due to the back and forth, forward and backward, or back and forth motion of particles of the medium. Another example of longitudinal wave is a sound wave. Sound waves or sound form a vibrating body also produces longitudinal waves in air. So these waves reach our air and then they vibrate, produce vibration in our eardrum. You know that there is a membrane in our ear which is called eardrum. So these vibration when reaches our ear, they produce vibration in our eardrum, and then we become able to hear the sound. So example of longitudinal waves are the slinky spring, and also the sound waves are the examples of longitudinal wave. I told you a wave in which particles of a medium move back and forth or forward and backward parallel to the direction of wave is called a longitudinal wave. In longitudinal wave, we have an example of a slinky spring. When you pull or push a slinky spring, you will see the compression and rarefaction will produce in the slinky spring. And you can see that in longitudinal wave, the particles of the medium and the direction of wave is same. Wave is moving from left to right, also the particles are moving from left to right. Only the particles form compression and rarefaction. While in transfer wave, you can see the wave is moving from left to right, but the particles are moving up and down. This up and down movement of wave or the particle of the medium is called perpendicular movement of the particles of a medium on the direction of the propagation of wave. Wave is moving from left to right, but the particles are moving perpendicular because they show up and down motion. Up and down motion means perpendicular. But no up and down motion, just a straight motion. It produces compression and rarefaction in the longitudinal wave. So these are the two important types of waves, transverse waves and longitudinal waves. As I told you that sound waves are also longitudinal waves, and this is another example of the longitudinal wave. In the previous slide, we discussed the example of slinky spring, and second example of sound waves are the longitudinal waves are the sound waves. So when you know that a sound wave traveling through air is an example of a longitudinal wave. When a drummer beats a drum, you can see here a drum, and when a drummer beats the drum with this stick, what will happen? The membrane of this drum will start vibration. Due to vibration of the membrane of this drum, what will happen? Waves will produce. Those waves which are produced in the drummer, what will those waves do to the air which is present in the surrounding? These lines actually shows the disturbance in air which is present in our surrounding, and this is the disturbance in air when reached our air. This is our air. Then it causes vibration in our eardrum. Then we will be able to hear the sound. So this is our air, and these Wi-Fi lines are for the disturbance in air, which produced due to the vibration in the membrane of the drum when the drummer or when a man who beat the drum, when he is called the drummer. So when a man who beat drums or who play drum is called drummer. When a drummer beat the drum, what will happen? Vibration will produce in the membrane of the drum, and due to that vibration in the membrane, it will also pull or push the air which is present in the surrounding and will produce disturbance in the surrounding. When a drummer beats a drum, the surface of the drum vibrates, the membrane of the drum vibrates and creates a disturbance in the air beside it. So the air which is present at its side, at the right side or at the left side, what will happen? These vibration in the membrane will produce disturbance in the air also, and when the drum head moves, when the drum head moves to the left, it compresses the particles of air, and air particles create a compression. When the membrane moves at the outer side, when the membrane is moving at the outer side, it will push the air back. So due to pushing of the membrane to the air, what will happen? The air particle will come closer to each other, and then they will form compression. Compression will produce. And when the membrane will move at the inner side, what will happen? Then the air particle will relax, or they will move farther apart from each other, and in that case rarefaction will produce. So compression and rarefaction in air will produce due to the vibration in the membrane of the air drum, which in turn disturb the air which is present beside the drummer, or beside or in our surrounding. So due to that membrane movement, when it will move out, it will push the particle close towards each other, and then they will form compression. And when the membrane move inside, then the particle will relaxed, and then they will move farther apart from each other, and then in turn will form rarefactions. So when the drum head moves to the right, the particles of the air on the right move farther apart, creating a rarefaction. These compressions and rarefactions travel through the air as longitudinal waves, and when the disturbance in the air reaches our air, this disturbance in air, when it reaches our air, it produces vibration in our air membrane, and then in turn we are able to listen the sound, and that vibration actually which produced in our air drum causes or make us able to hear the sound. Without the vibration of the air drum, we will not be able to hear the sound. In this case, they say that when the drum head moves to the left, it compresses the particles of air. So just keep in your mind that this, like while you are watching the video, you will say that this is your right side, but actually this is the left side. And this in the diagram, this is the right side. The left side is the right side, and right side is the left side. In diagram, you have to consider it like this. So this is that when they say that when the drum head moves to the left, it means they are talking about this right side. And when they say the drum or the particles move to the right, so this is actually your left side. Okay, so don't get confused in this. This is the left side in diagram, and this is the right side of the diagram. So when the drum head moves to the left, it means to the right, it produces compressions. And when the drum head or the membrane of the drum moves to the right, which is our left, then what will happen? Rarefaction will produce. So don't get confused in the left and right side of this. So dear students, this was all about the waves and types of waves. Inshallah, the remaining topics of chapter number 10 we will discuss in our next lecture. Till then, take care. Allah.